So this is a video on chemical transmission. So basically what happens here is that this is a presynaptic neuron and this is a postsynaptic neuron. What's going on is the dendrites are getting signals, right? And it's getting enough signals that it's going to create an action potential. So the action potential is going to come down, and the voltage is going to open a voltage-gated calcium channel. So voltage-gated calcium channel. And so calcium is going to come in. It's going to help these red circles here bind onto the cell membrane down here, right here. And so calcium is going to make this go down here, and it's going to release the contents of the vesicles here in a process called exocytosis. A good way to remember it is that exo sounds like exit. The vesicles are trying to exit. And so this is what calcium is doing. And so there's going to be a lot of neurotransmitters in the synaptic cleft. So in the synaptic cleft here, there's going to be the neurotransmitters, and they're going to bind onto a receptor on a postsynaptic neuron. And so there's two kinds of responses that will happen when on different kinds of receptors. So there's two kinds of receptors. This one will bind onto this one, and what will happen is it's going to open this receptor and let an ion in. So it's called an ionotropic response. And so in for example, with antidepressants, it will let chlorine in, or anti-anxiety meds, it will let chlorine in. So there's an ionotropic response. It's letting an ion in. That's how you know it's ionotropic. In the other case, in a metabotropic response, it'll bind onto the receptor. The receptor will talk to a cell, talk to another cell, it'll talk to another cell, it'll talk to another cell. So it's called creating a cascade, a cell cascade. And this is the metabotropic response. After the response has happened, this is the receptor. After the response has happened, the neurotransmitter is removed, and that's it. That's the end of the transmission.